All right, so for today's class, we're still looking at solving questions with square roots, squares, and so forth, but we're going to focus a little bit more on simplifying radicals. All right, new word, radicals, we already know it. It's anything that deals with square roots. So if I say square root 2, that's a radical. Period. All right. So we're simplifying radicals. For learning intention, it says we are learning to combine properties of equality and equivalent expressions in order to write equivalent equations, inequalities, and formulas. And then for learning intent, for success criteria, it simply states, I will be successful when I can solve or I can simplify radicals. We'll go over some radical questions and then we will check out some Desmos worksheet and then a good quiz. All right, so one of the first things we're going to look at is identifying perfect squares. We've already talked about what perfect squares are, perfect squares, but I want to go through again and just talk a little bit more about it. Perfect squares is whenever we find a square root of a number and you don't get a decimal point, basically. So the square root of 4 is 2. That's a perfect square. The square root of 16 is 4. That's a perfect square. The square root of 25, I'm basically going through all of them, is 5. The square root of 36 is 6. The square root of, what's another one? 49 is 7. The square root of 64 is 8. The square root of 81 is 9. Oh, I missed out that one. Thank you. The square root of 9 is 3. Oh, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 100 is 10. The square root of 121 is, so it's basically all the numbers on the times table where it's multiplying itself. 2 times 2, 4. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7 is 49. You go through, those are considered perfect squares because you get the exact number. There's no decimal, nothing. All right, that's it. And you could go even more. Square root of 144 is 12. 12 times 12 is 144. Square root of 169 is 13 because 13 times 13 is 169. All right, so then what we're going to be focusing on is simplifying radicals with perfect squares. So we just identify what these perfect squares are, and I'll do some of the questions from the worksheet just to start out. Let's get a new sheet. So you remember when we did some questions and I told you that we could split up the square root? So for example, if we have square root 4, we could split this up and say that's square root 2 times square root 2. We're splitting it. So that's what we're going to be focusing on, but with perfect squares. So my first example is the square root of 75. If I should find what the perfect square is in 75, I know 25 is a perfect square, right? Square root of 25 is a perfect square, so I could split this up in square root 25 times square root 3. Because 25 times 3 is 75, but then I also know that 25 is a perfect square. The goal is to get one of these numbers to be a perfect square. The goal is, I'm going to say it one more time. The goal is to get one of these numbers. After I split it up, I want one of these numbers to be a perfect square. So then I could go in and solve this even more. Square root 25 is 5. And then the square root of 3 is not a perfect square. so I'm going to write it back. So the answer is going to be 5 square root 3. It's like I'm saying 5 times square root 3, but I'm just going to write it back because it's not a perfect square. That's it. So you know those questions we were doing where you had square root something, and I said just leave it like that for now. If there's a perfect square in there, break it down like how we do this one. Let's see how we do this one. The square root, I'm using the green marker now. The square root of 50. How can I break this one up? Recorded. All right, so this right here we could split up in square root 25 times the square root of 2. Like I said, this could be broken down into square root 10 and square root 5 because 10 times 5 is 50. However, we want to include a perfect square in there. Okay, so equals 5 square root 2. 2 is not a perfect square, so I'm not going to go through the hassle of finding the decimal and all that. I'm going to leave it like it is. Talking about. Let's do, I'm going to change colors. Blue. Square root 12. How can I break that one up, which includes a perfect recording? If I'm breaking this one up, I'm getting some answers that says 6 and 2. 6 and 2, yes, you could break it up in 6 and 2, but is 6 a perfect square and is 2 a perfect square? No. All right, if we find the square root of those, we're going to add decimals. So we have to break it up in square root 4 times the square root 3. Because we know that 4 is a perfect square. The square root of 4 is 2. And then we can't find the square root of 3. Like we can, but it's going to give us a decimal. So we leave it as is, 3. Let's do one more quick example. Actually, let's do 2 more. So square root 28 and square root of 175. Let's do those two. The square root of 28 and the square root of 175. How would I split up? Let's look at the first one first. How would I split that one up? I would split this one up with 7 and 4 because square root 4 is a perfect square. And then there's square root 7. Square root 4 is 2. And then I'll just put back square root 7. What about this next one? How would I split up 175? So it's square root 25 times square root 7, because 7 times 125, 7 times 25 is 175. So then my answer is 5 square root 7. Next question. Let's do square root of 72. There it is. So square root of 9 times square root of 8, because 9 times 8 is 72. 9 is a perfect square. 8 isn't. So then the answer for this is 3 square root 8. And pause. End this. And that's how you simplify radicals with perfect squares. If you have any questions, let me know. Stop recording.